So, ladies and gentlemen, we are coming to a super interesting topic, at least from my point of view. I have kind of an addiction to 3D printing, or I would rather call it additive manufacturing, but this is exactly what we want to talk about. Is it still 3D printing, or is it already additive manufacturing? And our next speaker will probably solve that question and answer that question. One quick question to the audience. We have a few here. Who has already a 3D printer at home? Nobody. Ah, there's one. Very good, very good. So who is familiar with additive manufacturing here in the audience? A little bit, there at least. It's a fantastic technology, I can approve that. So the next speaker comes from Switzerland, will tell us in English what his product is about, and he will show us how they got from 3D printing, from simple 3D printing to industrial additive manufacturing. And that's worth a speech, in my opinion. So please welcome with me Stefan Lang, who is CEO of IRPD AG from Switzerland. Big applause, please.
Thank you. Very nice good morning, or as I have to say, good afternoon to you, everybody. As it was introduced, my name is Stefan Lang. I'm the CEO of IRPD. We do have almost 30 years of experience in additive manufacturing. Until this year, we were a job shopper, so people sent us their data. We created parts in polymers, but also in metal. But since 5 years, we are now focusing, or we have focused actually on the development of an additive machine tool, which we believe will revolutionize the market. And this is also the topic of my presentation, going from 3D printing to additive manufacturing. So if we look at 3D printing is known for samples, it's known for prototyping, it is experimental, I would say, low performance, uncertain reproducibility, uncertain quality, I would call it the 3D printing, and also probably assigned to all of that as a result would be a rather result in high cost. Now, if we take a step on the side and we look actually at additive manufacturing, and this is a whole new ball game. In additive manufacturing, we design for serial production, not anymore the prototyping, but really small, medium series, even up to bigger series. There are companies who produce on a daily basis 250,000 parts per day additively. So really, this technology, after the hype, has now really arrived in the really reliable production. It is optimized for production. It brings high performance, high reproducibility, exactly the same quality, part 1 as part 100,000, as I print maybe the same part in 100 years from now, or maybe only in 50 years, so it is become plannable. Reliable quality, that's also something important. It's not only the output, but it's the quality which counts. And it's also optimized already for post-processing. Probably many of you who know additive manufacturing, the part coming out of the printer is not yet in the age of Star Trek, where you have a replicator and you get from spaghetti carbonara to engine parts already finished. Additive manufacturing still requires post-processing, and that needs already be thought in when you talk about additive manufacturing. And also important, that this is the case I brought with me today, is optimized for price. So let's look a little bit at what are the reasons why you manufacture something in additive manufacturing compared to traditional methods. If you look at traditional methods, if you do milling, if you do routing, if you do turning, if you do grinding, please stay with that process, because probably it's the most economic way of manufacturing. But if you need to solve problems where the traditional methods come to their limits, then you have a chance of solving those problems by using additive technology. So what we can do really complex geometries and design. We have material efficiency. I only need the material which is converted from powder to a part. So all the waste powder which is not melted, I use it again, and I can use it for many different parts. It's not trash, it's not waste, it will be reused just in the next process. I can merge components, as we'll see in the example I have with me. I can cost effectively make very small series, but also to big series. I have the same repeatable cost. I have the possibility of personalizing items, reduction of production times. That's also, I can do supply chain optimization. I'm not relying on a very long and maybe unreliable supply chain. So that's also something I can produce in-house, the parts, and I'm not relying on any suppliers. An important factor, lightweight construction. If we are talking about economics, as I mentioned, I only need to convert the powder into parts where I need it. It's lightweight, and that brings also a lot of benefits for further use of the products. What is also important is, or maybe an idea, is hard to machine parts. I can actually make the basic structure with additive manufacturing and do the finish then with machining, with CNC, with grinding, with milling, which brings it then to the perfect shape. It's another game changer how I can optimize production. And last but not least, also to increase the product performance. Let's look at the part which I really like. We did an analysis and I took this part with me. This is not my teddy bear I take always on stage, but this has to do with my presentation. If you look at this part, this is the original manifold for hydraulic distribution, and this is how it was manufactured in the past. We had actually 4 parts which were milled and then stacked together. They had to be mounted to get the functionality I have today with 1 part. Really complicated and iterative design process, complicated, long-term, many loops, and very time-consuming. And if you look at what is possible today, so if we really use the technologies available today, then you can actually go for something along this line, which really brings a lot of potential. We have 90% of reduction of design time. There are engines, computer engines to design such parts, such for example as Grasshopper Rhino, where I just define the entry and the exit points, I define the structure, and automatically it will come up with a design which I can use for 3D printing. I have 70% less weight in the final design, 65% reduction in component size, minimizing pressure loss because there is only 1 part, it's not 4 which needs to be brought together, fewer individual parts that reduces the headache of stock keeping, and less leakage as already mentioned, and I can also do customer specific design, which is another advantage. If we look at the metrics, I mentioned about serial production, and I have here an example. If I would like to produce this part in a serial production, and this just as an example, on our machine, I'm from IRPD, so I would like actually to emphasize the performance on our machine, but I can do 16,000 of this part just with 1 machine, and this is really, we are not talking about prototyping anymore, we are really talking about serial production. So how does this look like on manufacturing cost? What is the benefit? And I think this is something interesting to see. If I look at the printing cost of this part, we talk about 105 euros is in a bigger series, and this was calculated with a serial size of 5,000 pieces per year. I get about 105 euros per part. The post-processing, all the machining, we add another 15 euros. This equals about 120 euros for the final part, and this is about the cost of such a part. So if we think about additive manufacturing equals expensive, then these times are over. Today we can actually already manufacture in a bigger series already very cost efficient. If we compare this part, any guesses how expensive this part would be in traditional with the 4 different elements we put together? Any guesses of the audience? I can resolve that already for you. It's also 120 euros, but it's not only the price, but it's the performance, it's a lighter weight, it's all the benefit you get through additive manufacturing, which really makes the difference. And how is that possible? Possible, this becomes with the machine. I'm very proud, I'm the CEO, this is my baby. This is the Impact, the 4530. The name already indicates we have a building size of 450 millimeters by 300 millimeters by a height of 400 in height. So quite a sizable production area I can use in my machine. This really is a game changer. We are here not talking about 3D printing, we are really talking about additive manufacturing. Additive manufacturing requires a machine tool, and this is just a different category. And if you are visiting us at our booth in Hall 11, booth E45, you will see what I mean with a machine tool. It is 9 tons of solid engineering, and this is what you need to create such parts, 12,000 per year, in a very reproducible manner. So I already mentioned quite a large build area. I can stack many products onto one building plate. I have up to 4 lasers with 1,000 watt of energy, so 1 kilowatt. Each laser reaches every spot on the building plate, so also highly efficient. I get a very high output. I can build in 30, in 60, in 90, or even 120 microns per layer and really get really fast result, and even with that, a nice surface. So after my presentation, if you would like to have a look at the part, I'll be here in the area. You can certainly also have a closer look at the product itself, at the final product. So I have actually prepared a small video that maybe as a teaser that you will show or come to our booth. This is the machine, how it's built. And we are very proud. It's a Swiss-made product, engineered in St. Gallen at IRPD and built at Studer in Steffisburg. This is also in Switzerland, close to Thun. We have a concept with containers. So we are moving in containers. So this is very efficient. We go job to job in 15 minutes. We can go material to material in about 4 hours. And this is really a workhorse. This is a machine tool for the additive manufacturing. Here you see how really the part is growing layer by layer. We are adding, it's always the top structure which we are melting with these 4 very powerful lasers, and then actually the structure grows, and at the end I have a final part. I do have a container which is filled, and here maybe you can see a little bit the secret on the inside of our machine. What I would like to show you, number 1 and number 2, this is our container concept, and this is really allowing us for industrial production. We have number 2, this is the powder container. So we have a filled powder, a metal powder. It can be different steels, it can be aluminum, it can be titan, it can be Inconel. So everything which is weldable can also be powderized and used on our machines. Theoretically, the materials I mentioned before are those used today, where we can also provide recipes, but that's not the end of the day. I guess every new year, every new week, there are also new materials coming to the market, and we are gladly to support your needs, your process on the material quality. Number 1 is also important. This is our build plate or our build container. And this has 2 parts. One is the overflow, where with the coater, if we move the powder from the powder container to the build plate, of course there will be some leftover, and this will fall as a recycling, or we can later use the powder again for the next process, will fall into the overflow. The important is in number 1, the bigger size. This is my build plate. There is where the magic is happening. There I'm building layer by layer. Interesting, with the machine concept, I can feed containers from the back. So already in the DNA of the machine, you have automation. We feed containers from the back. As soon as the job is done, the containers are closed. We put a lid on the container. They're inertly filled with inert gas or with shielding gas. We close them, we exit them from the machine. We insert a new set of containers, and within 15 minutes, we can go job by job. And through the feeding, through position 3 on the back of the machine, we can even automate the process, and that really allows us 24/7 operation, and this is really what, in my opinion, defines a machine tool. A machine tool doesn't only mean fancy technology. A machine tool is also rock solid, and this is what you need for really a reproducible production of additive manufactured part. Our build core has a weight of 6 tons. And this mass you need, if you see any other equipment and you look at that from any other company offering additive manufacturing machine, or I would call those 3D printers, they are not as solid, but you need this solid core to have the stability, to get very nice surfaces, to get reproducible result, we need this mass. And also this build chamber is not only mechanically stable, but also temperature stable. We are using the shielding gas plus also water cooling to make sure that during the production process of several hours typically, that we can maintain the same environmental condition, ensuring that we really have a reproducible, good quality, which is fit for the purpose. One additional thing I would actually like to mention, which has also to do with serial production, and this is also something new, which you will not find in any other machine, which is displayed here or displayed at any other show. We call it the multi-function coater, and this has a specific design. What it does, it is packed with sensors to measure in the build plate. It has the function to lift and to reattach the lids for the containers. And last but not least, you see actually the drum on the lower side of the number one, or number two. This is the multifunction coater. Anybody familiar with additive manufacturing, it can happen actually, especially if you have material as an Inconel, that the tension in the material makes a material, a part, sticking up. And what does is that you actually get a dent on your coater. A coater is like a lip, a very soft lip, which we use for distributing the powder over the build plate. If that has a dent, we are recognizing that. We have cameras on board. We have a monitoring of the powder bed. If we see any anomalies in this powder bed, we can actually switch to, without opening the unit, we can automatically switch to the next coater lip, really offering 24/7 operation. Our competitors, if they have a lip failure, they need to reopen the machine, they need to leave the vacuum, they need to leave the inert status. We can just continue, we void the part which has caused the problem, we apply more powder, and we can continue the process. And our build job, which is running for hours, we can save and we can still have very good parts. So this is really what I mean by a product which has capabilities of a machine tool. Here you see actually how it looks in our machine. This is just a display, but you can actually see in this picture the 4 lasers, 4 times 1 kilowatt, very powerful. The lasers, they can reach any place on the build plate, so that's one feature, and very powerful. And you see in the picture here, the lasers are working. Each have products or final parts assigned. This is certainly a way how it can be done, but we can also work with several lasers on one part if we have bigger parts. This is called multi-hatching, and certainly our machine can not only do many small, but also big parts, and multi-hatching is really the key to have a very high productivity. Besides the productivity of the machine, it's also important that you get very good data, that you get reliability, that whatever you have built, you have the confidence, you have the knowledge that what you're building has an excellent quality. And that's the key, and I think that's the second criteria if we talk about the machine tool. It's really the quality which comes out of the machine. We have different technologies built in. We have different cameras. We have on-axis camera, we have off-axis camera, we have pyrometers, we have a lot of sensors, and with every build job we are providing so much data that afterwards, after the build job, you have the certainty with the job report. You know exactly at what point in time you had heat, where, how was the heat distribution, what was the oxygen content. You can set limits, and if you are within the boundaries, then you have a good confidence that your product is reliable and is fit for use. And that's another factor beside the productivity, is this monitoring to ensure that you have an excellent product quality. The third component for a machine tool, in our opinion, is automation. So the first 2 things, we looked at productivity, we looked at the quality. Third thing is automation, because a machine tool you want to use 24/7 for several years to really get the most out of the product. This is just a concept, but it's in the DNA of the machine, how it was built, that this container handling can be fully automated, that we take containers from the machine, we reapply containers, we continue the operation, and that's actually the third factor why we can, with good confidence, say this is a machine tool for additive manufacturing. The products are made, and here you see actually a glimpse into our production. The products are 100% Swiss made. We have the development with a team with IRPD in St. Gallen. We are a team of engineers. We have all the R&D in St. Gallen. We have the sales department. We have after-sales service. That competence we offer in St. Gallen, Switzerland. The machines are built at Fritz Studer, which is probably a very well-known name, certainly one of the leaders in machine tools. And these two knowledges, our 30 years of experience from additive manufacturing, plus over 100 years of experience in machine tool, we have added that together, and the result is the Impact 4530 machine. And this was just a glimpse into the production capabilities we have. With that, I have mentioned, or I summarized, and probably I went a little bit ahead of time. I would be open if there are any questions, if there is anything I can further say. And at the moment, maybe I can run down, or there is actually a question in the back. Would you take that question and bring it back, or how would that best work?
It's totally easy. So if you want to ask a question, so she doesn't want to ask a question, no, it's no problem. So first of all, thank you for the presentation.
Thank you
very much.
very
It was very energizing, and it creates a lot of engagement.
Thank you.
If you want to ask a question, make it easy for you. Just scan the QR code, ask the question via Slido. So I do have a question up front. So we were talking about the build chamber you mentioned. So what is so the typical customer you have for your machine, so that we sort a little bit out for the audience here?
Sure. I mean, one thing is certainly the big build chamber, which allows us to make big parts. That's one thing where we have industries, and one part is the industry, but we cater also to building of aeroplanes or aerospace industry. We are caring also to the medtech industry. We have job shoppers within our customers. We have research institutes. And the good thing is the family we are in now with United Machining, with the grinding, with the CNC, with the routing, the milling, the EDM, all these customers which work in metal, additive manufacturing is just in the process chain one before. And so we already own, as a group, we have our customer. They are already used to the fantastic quality, to the fantastic service. And as a group, we just want to extend the production chain to one step further.
What I really like was your entrance remark, or the title of your presentation, from 3D printing to additive manufacturing, because as you know, I'm long years in the industry of additive manufacturing. That's always the thing we hear. Is it really industrial production? So what is the scale? So you mentioned the scale.
Yeah.
So do you see at your clients that they really that they really got it in terms of, do they realize the potential already, or is there room for improvement?
Very, very good point and very good question, and thanks for asking it. I would say the point where additive manufacturing is just for prototyping, those are over. But if we're talking about a series of 10 or 50 of 100 or of several thousands, I mentioned the customer who builds 250,000 parts per day. That's still the exception. That's not the normality. But the technology today is actually ready to go that step. And I think this is really the time where we witness that revolution. If we look at additive manufacturing or 3D printing, this was a hype 4 or 5 years ago, and people had wild ideas. Now, this hype time, this is certainly over. Many people lost a lot of money in this industry, but now it's a different market. Now it's really after the hype, and now it's not about promises, but now it's about proving, and this is really certainly a new area. And with this technology, we can certainly prove this is ready for serial production.
One important thing, in my opinion, at additive manufacturing is that you start thinking additive, because as you mentioned, you have so many advantages regarding the product design that normally are not seen when doing it traditionally. So how do you bring it to your customer that they do understand, listen, it's not about only the part cost, which most of the time is a dominant perception on the part. So how do you bring that to them and explain it? What kind of use cases do you present?
I think one of the important slides I've shown were really the advantages of additive manufacturing, and I think there is the key. In this example, we were equal cost against traditional manufacturing, and there is a way of traditionally manufacturing, and by good luck, we were at the end, we had the scale balanced on exactly the same price. Usually, if you can do something traditionally, keep on doing it traditionally, you're fine. But if you think about combining product, if you want to bring cooling, if you want to bring fluidics into the product, if you have additional functionality, the lighter weight, if that's a benefit, there is the point. And it's not a purchaser or it's not the shop floor manager, but it's top management in companies who really need to think, how can they differentiate? How can they build better products? And then we are there really to take their hand and walk them towards in the additive manufacturing. But it's, as you mentioned, I think your words were absolutely perfect. It's a mind change which needs to happen. And traditionally, many engineers today, they do the same thing like they have done the last 30 years. And some people could say the definition of intelligence is that you rely on past data and you project that to the future. But here, really, this is a game changer and it requires different thinking. With every new technology, there are innovators, they see the advantage, they go for it. There will be laggards, and I don't know what the price would be to be in a laggard company, but there is certainly some opportunity.
There's a very interesting question that you might have to answer anyway at your booth. So what does a machine cost?
Very good question. So it's not that much, but it's still, if you want to have a machine tool for additive manufacturing, this is not your filament printer you have in your home to build spare parts for your kitchen. This is an industrial machine, and it starts just below 1 million is the basic machine, and then it can be, there can be upgrades, there can be more sensors, but this is really a machine really built for 24/7 operation, really over many years. And if you can really save and if you can really make parts, I would say the payback of such a machine can actually happen pretty quick.
So as we are at the EMO and we are considering different materials being used for production here with the traditional production methods we have, probably you allow me the question talking again about durability, because you tackled it in your speech.
Yes.
But anyway, we're talking about metal additive manufacturing. Yes. So there are high preconditions regarding durability, quality, weight, structure things. Sure. So how would you compare technology additive manufacturing nowadays, especially in metal, with classical production methods?
Okay. I mean, if we look at the density we can achieve in such materials, we can easily go 99.8, 99.9 is the density of the material. The material process is we go really layer by layer and we melt every layer, we melt freshly. With melting, we are also melting probably 2 or 3 layers below. So the material is melted 3 times, so it gives really a fantastic product quality and really high strength. With the density I mentioned, 99.9, that's certainly above casting, way above casting, where you can be lucky if you get above 95. And we are very, very close already if you go from solid material and just the benefits. What you do if you have additive manufacturing, you go for bionic design, you go for optimized design, which if you have difficulties, which you can cope for it, and it's just overcome by design. The materials are getting better, technology is getting better, and so today, 50% of the newest airplane engines are already manufactured additively. If we look at other parts in the industry, I mean, medical implants are manufactured really where it counts. It's additive manufacturing. Siemens Energy, for example, they say their turbines for electric production, they have 30% longer life compared to traditional manufacturing. So it's not only matching, but by far exceeding the capabilities, because we can do temperature management within the part, which is a big benefit. So I would say in many cases it can surpass traditional methods.
Awesome. Awesome presentation, awesome answers to the question. Thank you so much. Big applause, Stefan Lang, ladies and gentlemen.